Let's look at division of complex numbers. So let's take a simple example where we've got 3 divided by I. So you'll remember from school mathematics that if we have a irrational number in the denominator, like 3 over square root of 2, we want to rationalize the denominator. So we'll see that we don't want a rational number as the denominator. So to do that, we had to multiply by square root of 2, the top and the bottom, and the result will be 3 square root of 2 and divided by 2. So you'll see the denominator now is a integer, which is not irrational anymore. So we want to do something similar for complex numbers. So we want to rationalize the denominator. We do that by multiplying denominator and denominator with I. So if we do this, the top part will be 3i squared, and the bottom you'll see will be I squared, sorry, not 3i squared, just 3i. Just fix that. 3 times I, and I times I is I squared. And remember again, I squared is always equal to minus 1. So it will be 3 divided by minus 1, or just minus 3i. So we can take any complex number. So let's take an example of where we've got a complex number with a real number as well. Let's take 2 minus 3i divided by 2i. Okay, so again, we just want to normalize the denominator, and we multiply it by just multiplying it by I. So again, what we will have here is we will multiply the top, and we'll get 2i minus 3i squared, and the bottom will just be 2i squared. And again, remember, this is minus 1. So this will be equal to minus 1, and that will be minus 1 as well. So we get 2i plus 3 divided by minus 2. So it's 2 multiplied by minus 1 is minus 2. And then we will just write the real part and imaginary part separate. So the real part will be 3 divided by minus 2. So it's minus 3 over 2. And the integer, imaginary part would be minus 2i divided by 2, which will just then be equal to minus 3 over 2 minus I. So we'll see then this is the solution there. Okay, so this is when the denominator is just an imaginary number. But we can also get the scenario where we've got a complex number as the numerator and the denominator. Let's take 5 minus I. So again, we need to rationalize this complex number. Remember what we said, if we multiply a complex number with its conjugate, let's take an example. So in this case, we say v is equal to 5 minus I. So the conjugate of 5 minus I would be 5 plus I. And if we multiply these two together, remember the answer would always be a real number. So there will be no imaginary part left in that. Okay, so let's multiply by the conjugate of 5 minus I, which is 5 plus I. And we'll do that on the top and the bottom. Okay, so at the bottom, remember the imaginary part will always fall away, minus 5i plus 5i. So these two will always, that will always result in 0. So we only need to multiply 5 times 25, 5 times 5, which is 25. Let's go back here. So it's 25, and minus I times I, which is minus I squared. The top part we have to multiply, which is minus 10, minus 2i, and then plus 5i, and plus I squared. And remember what happens with the I squared. All the I squareds, this I squared would be minus 1, and this I squared would be minus 1. So that will leave us with the top part where we've got minus 10 minus 1, which is minus 11, minus 2i plus 5i is plus 3i. And the bottom would be 25 minus minus 1, which is plus 1, which is 26. So the final answer would be minus 11 over 26, which is the real part, plus 3i divided by 26. And that's how we do division of complex numbers.